Our final rule is the zero exponent rule, and this one, oh my gosh guys, it's so easy. You just need to understand that literally anything to the zero power, any base here to the zero power is just 1. So x to the zero power is 1. 1,000, the zero power is 1. J, K, Z, K, R, 300, all to the zero power is just 1. Now that's if the entire thing is to the zero power. If I have something like 3k to the zero power, I'll have to keep in mind that only the k is being brought to the zero power. So this is like a 3 times 1, so 3k to the zero power is really equal to 3. If you see something to the zero power and a really long expression, so if I have like 2x to the zero power y cubed over 4y squared, I get to the point where I just start scribbling these things out because it's like multiplying by a 1, and I'm just really not concerned with it at all. My answer would be 1/2 y, because I'd have 3, 2, and I'd be left with y to the first. So they're really like multiplying by a 1. Now, you do have to keep in mind, though, if I have something like a negative y to the zero power, there's really a secret little understood negative 1 out here that is being multiplied by this y to the zero power, which is like a negative 1 being multiplied by a positive 1. And so this really comes out to be negative 1. Now, if it had been a negative y to the zero power in the entire parentheses like that, then it just comes out to be a positive 1 power. So it is super, super easy, but just be aware of some things that might happen. Our two examples, again, like I just said, I've got 7x to the zero power. Only that x to the zero power is like a 1, so the answer to this is actually 7. Then on example number 2, I've got this power rule here. So w to the 4 to the second power is really w to the 8th over w to the 8th. If I did the subtraction rule here, that would give me w to the 0 power, which is just 1, and we could have seen that because it was the same thing over itself.